Well, welcome. We are so glad that you are here. And if you're a regular webinar attendee, you've probably heard some of how we approach things before, but so many new folks are joining us for these webinars. And I need to level set and just to make sure that everybody's on the same page. If you're signing up for these webinars, it means that you probably want to get more done. You want your team to move faster and you want them to produce higher quality. So that you can deliver for your team, for your company, and for your customers. And this series is .NET DevOps for Architects. It is guidance that is aimed squarely at software leaders who want to enable their teams to be world-class. And I believe that every team can be world-class when equipped properly. And I know from experience that if you map out your software delivery process and then you automate it, you will deliver more. It'll force you to deal with situations where maybe you've been kicking the can down the road, but you will deliver more. And you and your team will absolutely love programming again. Absolutely, no doubt. We have a big problem, an enormous problem, and a problem we're going to have to solve. Most teams automate work for their own customers by producing the software applications that you're working on. But then they saddle themselves with new administrative work to build and deploy and monitor software, the very same software that relieved customers of their administrative work. And there's no reason that the cobbler's kids shouldn't have shoes. And I work with teams all the time where one of their most senior, most capable developers is trapped by the task of deploying the software because he's the only one who understands the software the best. So they take their best talent with the most experience with the software and reduce him to weeks full of administrative tasks. Deployment is a set of administrative tasks. You copy files, you change a config file, you configure a credential, you start a service, you do it again and again, over and over and over and over. And we all got into software because we saw the tremendous power available. We can write code and make the computer do some really interesting things that make ours and our others' lives better. So then we shouldn't settle for a manual, error-prone, slow process. But whether you're an individual developer, if you lead a team, or if you're a manager in technology, this talk is for you, and this whole series is for you. Last week, we had an overview of the private build. We're taking the build topic and we've split it into two because it's such a deep topic. And last week we did private builds and a little bit is touched on that here. But now we're diving into the continuous integration build. And we're going to go through the common mistakes that people make and the three critical elements of a continuous integration build. And finally, I'll show you how to get started with this whole DevOps journey. Now, I want to give you something of value to help get you down the road, to help get you automated. And I don't want you to continue being sometimes frustrated or perhaps trapped by the very software that you work on. And we know that software always seems to find a way to break when you deploy. And I understand the lost weekends and the surprise of overtime because software builds and deployments going poorly. So at Clear Measure, we've helped thousands of professionals across over 40 countries be better at software. And my latest book, .NET DevOps for Azure, exposes the secret about how any team can have a fully automated DevOps pipeline by following a concrete 7-stage design. And the book, you can find it on Amazon now, .NET DevOps for Azure, a developer's guide to DevOps architecture the right way. And so here's what you need to do. 3 steps. First, read my book. And I am going to give you a free ebook copy, electronic copy right now, just for being here today on this webinar. So send me an email or chat with Rain in the chat and we'll get it over to you. And by the way, if you received this, the recording of this from your teammate who attended this, then I'll honor that offer for you as well. If you just send me an email, if you're watching the recording of this. So step 1 is read my book. Step 2 is really understand the 7 stages of a DevOps pipeline. which is in the book. There's 7 stages. And then 3, launch your .NET DevOps pipeline with Azure DevOps services, and use our public project as a model. You'll find it in the book. You can copy it. You can literally clone it and get up and running. If you do this, you will have a fully automated DevOps pipeline using all of what Azure can bring to the table, and that'll enable you to move faster and with higher quality. Okay. Now, if you want some deep, immersive, hands-on guidance, I am teaching my next training class on the 28th of October. It is coming up fast. Really excited. We have just a few seats remaining. I don't let these classes get too large because this is immersive, hands-on boot camp style training where you will learn in depth every aspect of what's necessary to equip you and your team with a completely automated DevOps environment, and you will implement it. You will walk away with the class, from the class with your own DevOps environment in your Azure DevOps organization. You're not going to walk away with just a binder of how to do it. You will have done it, and you will go back to your company as the expert. So sign up now, bit.ly/.NET DevOps Bootcamp. If you have any trouble, just send me an email. As usual, I love getting emails from you guys. And then another resource that could be useful to you is my podcast, the Azure DevOps Podcast. And we have some absolutely tremendous guests and topics. You can go to www.azuredevops.show. All right, so our series is the 7 key elements, or DevOps architecture, but the 7 key elements is what we're going through, and we are on builds. We've split that one in half, and we are diving into continuous integration today, and then continuing on next week with full system testing, which you do not want to miss, and make sure that you register now for that one. All right. So continuous integration mistakes. I have seen so many continuous integration attempts, and there are some common mistakes that people make. Everyone wants to do continuous integration. They see the possibilities, but they miss some critical elements. And just by being on this webinar, that I can tell that you are a cut above, because you're educating yourself on what continuous integration is, what the process should be, and what kind of things need to go into that process. The first mistake is not doing it. The first mistake is producing builds manually. That decreases cycle time exponentially. The second mistake is using one of the online quick starts, which essentially only gives you a continuous compile. Compiling the code is obviously needed, but that's not continuous integration. We need to fully integrate changes from our teammates to have confidence that our software is still stable. And you can't just compile the software and have that be your answer for is it stable. Remember, continuous integration answers that question for us. And we need the answer to always be, yep, with this change, my software is still stable, regardless of what the change is. Okay. Now, third, multiple build configurations. That's the third mistake. Multiple build configurations make things a mess. If you have a Git repository with an application, then you should have one CI build. Okay, that's the relationship. Now, if you have a system made up of 10 different applications, each of them has, each of those applications is in a Git repository, then of course, each one of those Git repositories would have a continuous integration build. That build produces a release candidate from what is in the version control repository. That's his job. And it produces the release candidate if the software is stable. It doesn't if something fails, and then you know that, hey, guess whatever happened just now destabilized the software, so we're going to stop the presses. Now, if you think that you're an exception to this rule, you aren't. I've seen situations where a single Git repository will have multiple versions of the CI build just to vary something, because you need maybe different things to happen, but they create multiple versions of the build configuration just to vary something that could easily vary using a parameter and a little scripting. If the build is implemented with no shell scripting, then it's hard to do it properly, and it tempts you to duplicate the build logic and create another one. A build, remember, a build is a piece of structured programming. Procedural style, not object-oriented, but it's structured programming. Given that it's programming, the dry principle still applies. Don't repeat yourself, DRY. And I'll show you how a little bit later. But these are the common CI mistakes. Stay away from them. Okay. Now, this is my Onion DevOps model. Some of you are familiar with my Onion architecture from back in 2009. And it makes me so happy that loads of people have found Onion architecture and found it useful over the past decade. They contact me all the time letting me know that their application uses Onion architecture and that their logical structure is simpler as a result. That's fantastic. So Onion DevOps is visualizing your DevOps environment using concentric circles. Okay, there are 3 views of Onion DevOps, and I'm pretty close to doing a full white paper write-up on that, but there's 3 views. The capabilities view, which if you are a long-time webinar watcher, then you will have seen the capabilities view. It's very colorful. This is right here that we're looking at is the cycle view. That's the second view. And then the third one is the logical view. Today, we're touching on that. We're deep inside the cycle view. Each circle represents a cycle. The cycle time of the inner layer is faster than those around it, as it should be. You want the coding cycle to be super fast, frictionless, but you also don't want huge cycle time differences in the outer cycles. For example, you don't want it to take a month to deploy a build that your team has declared ready to put on a manual test environment just because the build requires an environmental adjustment and some other team controls the test environment and you have to wait for them to do it. Okay, so the cycle time is really important. But these are the principles that we're looking for Onion DevOps for the cycle view. Now, let's also touch on the process view, because each one of these 12 steps on the left really should be a column on your Kanban board. If you're using a Jira board or a Azure DevOps, Azure boards, then you'll have columns in order to track your work and to track a piece of a feature or request from an idea all the way through, hey, it's in production. And each of these needs to be columns. So you've got your 4 types of pre-code design, but then you have 4 steps which are actual code, which a lot of times can be collapsed into 1 or 2 columns depending on what you and your team decide. So the middle sometimes is fewer columns, but that's up to you and your team. But this is the flow. Okay. Now we're diving into the smallest cycle, which is the code cycle. That's where we're living. Now, if I zoom into this, I can actually see the smaller cycles within it. Within code, within your local, you and maybe if you're doing pair programming, before you integrate with your whole team, run local at the very core is where you are just hitting Control F5, changing code and rerunning the application or executing debugging sessions, edit and continue, edit and refresh, running local. We all know that. The private build, we talked deeply about that last week, is what you do to make sure that what you just changed still operates within the whole and that you didn't accidentally break something else. And then the branch continuous integration is a team-based continuous integration build running automatically on your branch, which also receives back merges from master so that you know your changes play well with recent changes that have been accepted to master. Okay, and branch deploy deploys the product of your branch continuous integration build into a TDD environment, which is your fully automated, fully deployed environment. I have named it the TDD environment because we only do automated tests. There's no humans allowed there. We're going to provision it, or set it up, run the tests, and break it down. No humans allowed. So we deploy into that environment, and we run the full system test. And the goal of this is that it lets you know that what you just did will still deploy and will still start up, and it'll also pass the growing suite of full system acceptance tests, full system automated acceptance tests, because those run against your fully deployed environment. So continuous integration starts with the centralized build on your branch, and the same build will run on master after your changes are merged into master. Okay, so branching creates that little dimension, but you still have one continuous integration build, but we like to run it on our branch to know that it's ready, ready to go forward. And then of course, after our pull request, which we're going to go into that process next week because we're doing full system testing, which requires us to complete a pull request process. Okay, so we are going to spend our time on continuous integration, and whether it's run in a branch or whether it's run in master, it is the same process. I see continuous integration builds being adopted in a very thin way, and that's very positive, but it does leave a team with a false sense of security, thinking that the practice is employed, and then the team is frustrated because the promised increase in quality and productivity doesn't materialize. So I want you to, if you're in that boat, stop being frustrated by a slow development cycle. Stop spending time the next sprint fixing bugs created by the previous sprint. And over this week and next, I'm going to show you how to finish your CI build and get it deployed and run full system tests. And we're gonna go through that. I'm going to show you every piece of it. All right. So now let's look at the 3 essentials for a continuous integration build. All right, first, it must be complete. Of course you're going to compile, but you also need to decide what quality control checks that you're going to do in the build in order for it to be complete. A continuous integration build is a test, okay? So if you've ever done test-driven development, then the premise is the three steps are arrange, act, assert. You set yourself up, then you do something, and then you check in multiple checks that that thing happened properly. So this continuous integration build is a large test. It's a large validation. And, so it has to have the asserts or the quality control steps. So here's my starting point controls for any continuous integration build. You have to have a unit test suite, tests that don't call out of process. These are very fast. You can run thousands of them very quickly. Then next, you need to run a component level integration test suite. And that includes your database tests. If you're using Entity Framework, you're using an ORM or calling out to a SQL Server database, you need to make sure that those queries work, that your ORM configuration or your query works with the database schema that, guess what, might have just been changed by a teammate if they added a column. And next, in the continuous integration build for our controls, you need static code analysis. Doesn't matter what tool is appropriate for your application, you need static code analysis. There's Roslyn analyzers, there's JetBrains, ReSharper inspect code, there's a slew of JavaScript linters. Every language has command line static code analyzers. You need to use them. It will catch bugs. We also need to have automated database migrations. If your application uses SQL Server, you need to create your database schema at the beginning of your build process so that you can run your component level integration tests. And we'll cover later how a CI build should be set up using the same pattern as that test in test-driven development, okay? Now, it has to be complete, all right? Second, versioned. It must be versioned. Regardless of using YAML or maybe the visual designer in AzDO, which, by the way, AzDO is a short form for Azure DevOps, or even if you're using TeamCity or any other build server, your build must be versioned. That means that the meat of it must be in a script. PowerShell is the obvious choice. I'll show you later how the build server steps, I'll show you later how to integrate the build server steps with a PowerShell scripted build. And those build server steps are great, but programming in visual blocks isn't the right long-term solution. So regardless of build server that you use, make sure that you're using those built-in steps, those built-in blocks in there to integrate your build script and not actually perform step-by-step all of the logic that you want in your CI build. All right, and finally, your team must rely on it. It has to be relied upon. If it fails, stop the bus and fix it. The build answers that question. Remember, is my software still stable? And you want the software to always be stable. It is always a bad idea to think that you're going to destabilize the software to do something big and then come back around and restabilize it. Bad idea. Keep the software stable with every single change. You always want the build to be green, and you always want your build to have enough teeth, have enough validations, to have enough packed into it, where if anything destabilizing happens, your build is going to catch it. All right. Now, this is the structure, the process structure of your CI build. Let's kind of dive into it. We talked about the private build last week. And so we see that the private build and the CI build are very, very similar because they use the same base script. All right. They use the same base script. Almost every bit of the private build script is used in the CI build script. All right. But the steps, and notice that I've arranged the columns with arrange, act, assert, just like in test-driven development. So what things you need to do for arrange? Well, clean. We need to get rid of any past build artifacts, any temporary files, temporary directories that we had created. And of course, past builds create PDBs and DLLs. We need to clear out things, okay? Then we need to select what our version number is, and we need to stamp all of the artifacts that need to be stamped with a version number. With .NET, of course, we need to pass it into .NET.exe, and in .NET Framework, we need to use a common assembly info file. And if you've seen some of my past build script templates, you can literally copy that. The common assembly info pattern allows you to have one linked file that you just poke in the version number into that file. And then as the compilation happens, all of your .NET assemblies get stamped with the right version number, which guess what, is your build number. So configure your continuous integration server with the build number format that you want, because that's going to be your version number. Next, we need to migrate the database and any other environment setup that is necessary. Loads of .NET applications use SQL Server. So SQL Server database is the most understood environmental dependency that needs to be set up, but we're setting up our environment. That means that from source control, we run the database migration tool that executes our migration scripts in order so that on our local workstation, we have our own version of the database. And then we're going to do a compilation, which is our big act here. We're going to do the compilation, and then we're going to do asserts. We're going to run our unit tests, our component level integration tests. And then we're going to come back after that, because those things we ran on our private build as well. And we're going to do our static code analysis. Now, you and your team might decide that static code analysis should be in the assert column. If you're going to have some static analysis rules that are going to fail the build instead of a warning, that's awesome. And that is a point of maturity that I encourage you to work towards. But don't beat yourself up if you're just adopting it for the first time. Just getting the information that you have thousands of warnings is going to be useful to you. And then after static code analysis, we need to publish the test results to the build server. And then we need to package up the deployable application components into the various release candidate packages and publish those over to Azure Artifacts or whatever technology you happen to be using. Okay, so this is the structure that your continuous integration build follows. And you know what? For those you might know that aren't even doing .NET, they're doing something else. They're doing Python or Java or Node with JavaScript. Great. The tools are going to be different. All the steps are going to be implemented a little bit differently, but these are the steps. This is the structure. This is not .NET specific. This is the structure for the industry for a continuous integration build. Okay. So make sure that you have something that fulfills each of these boxes in whatever form is appropriate for your environment. All right, so let's keep going. Now, we talked about package and publishing those package as the last step. Let's touch on that, because release candidate packaging is the last part of the continuous integration build when, hey, everything's passed, we're good to go, we know we have a good version, and we need the build to finish transitioning from code to deployable artifacts. Because once the continuous integration build finishes, we are then dealing with deployable artifacts. We are no longer dealing with raw source code. So in the example application in my book, in our online project template, we have a web application with an offline job and a SQL Server database. And then, of course, we have our full system acceptance test suite. So we have 4 things that need to be packaged up as release candidates. Okay, they're all going to be the same version number, but there are 4 things. We're going to need to deploy the website. We're going to need to deploy this offline job in some fashion. And we're going to need to deploy the SQL Server database. And we're going to need to deploy the right version of the test suite, because it runs against a fully deployed pre-production environment. So we are going to end up with 4 NuGet packages, and those NuGet packages are going to go into Azure Artifacts. Now, if you've been using TFS or Azure DevOps Services for a while before Azure Artifacts came around, then you're probably using just the build artifacts function, which essentially is a glorified file share, and you might be using zip files, and you want to look at moving where you're storing those to Azure Artifacts, which is a full-blown artifacts system that supports all of the various clients. It supports universal packages if you want to use a zip file format. But if you're just getting started, NuGet is your format. You're going to have a nupkeg file, nupkg.nupkg. That's pronounced nupkeg. And yeah, there's all these various abbreviations, just like Azure DevOps is pronounced, AzDO for short. But this is the release candidate packaging at the end of your build. Now, let's look at your Azure Pipelines CI build configuration. Now, YAML first was announced in May, and they are making improvements, and some people are adopting the YAML format, and eventually everything will go YAML. And so that's more of this logic that can be stored in your Git repository, and that's great. But the editor and discoverability of marketplace tasks and the whole experience around YAML is still being worked on. So if you are just getting started and just jumping in here, use the steps to get things working, and then make a decision with your team on if and when you want to go to YAML. But if you're just getting started, this is what we still recommend, because YAML support was literally just released in May, and they're still working on it, and it's maturing, and it's going to be great, but it's just 2 parallel ways that you can configure. But most of your logic is still in your PowerShell script. Now, in this particular build configuration, we are all Azure paths. Before we do anything, no environments exist, which is another layer of sophistication, because I know a lot of you have VMware or Hyper-V environments where you have a set number of servers that you're working with, and that's fine. But if you want to go Azure paths, then these first 2 steps are going to create the SQL database in Azure, and we're going to create the database for our continuous integration build to run. Then we have a PowerShell step to run our script, which we'll dive into in just a second. Then after that runs with the versioning, the cleaning, the versioning, the compiling, the two different test suites, we're just going to wire up our test results to Azure Pipelines so that it has the results. And then we're going to push what was created to Azure Artifacts with the NuGet push step. And then we're going to tell Azure, hey, delete the resource group that I just created, because I don't need that database around anymore. All right. Now, this is the build script step. Notice that we are calling build.ps1, and we're passing in an argument so that we run the function CI build. Okay, let's dive into the structure of that build.ps1 file, which, by the way, the URL I gave you for the public project, it has all of these files. You can literally copy right now today. You can go to the public project and you can grab this file and you can copy it and you can use it for your project, please do. This is meant for you to get traction and for you to get going and make your life better. So please copy everything that's here. You don't need to worry about trying to do screen captures or whatnot. You can literally go get these source files, copy the entire project, including all of the build configurations, and get it up and running. And in a few weeks, we're going to show you an actual automated way to provision everything soup to nuts and go from 0 to a fully automated and deployed application shell in production in Azure within 2 hours. Okay. Now, if you can't wait, and if you need some help, if you got a project that's up and running now and you can't wait for that webinar, send me an email. We'll help you out. Okay. So we showed you this last week because it's the same build script as the private build. These are the different functions. And we are calling the CI build function, which, you know, for private build, we call it the private build function. Now, the parameters, if you remember from last week, are at the very top of the file. Now you see these at the bottom that test to see if they're null or empty. And if so, put in a default value. But beforehand, they're being populated from an environment variable. Okay, that's key. Azure pipelines for the CI build configuration, your variables will be placed into environment variables for running the PowerShell process. Okay, so every variable in Azure pipelines gets streamed and is available to this build script. Why? Not because it's special, but just because that's the way Azure pipelines works. And any variable you declare is available as an environment variable for any script that you run. Okay, so this enables us to have our private build use the same script with a few defaults, but it enables our continuous integration build to pass in variables and specify where the database is going to be. It's going to be in Azure SQL, and also look, version. But on our private build, we don't need versions, so we just hard code it to 9.9.9, so it's easy to recognize, oh, this is a private build. But we're going to grab that version number, and that's going to be passed in. Okay, you see right here, version equals environment.version or :version. All right, so then we have init and compile. We're not going to go over these again. We went into these in detail last week, but these are still used for continuous integration. We need to clean up and delete some, remove some directories. That's RD, and then we need to make the directory again, and then we need to compile. Now, this is .NET Core 2.2. We're about to upgrade our free template to .NET Core 3, which just came out at the .NET Conf a few weeks ago. But this is .NET.exe, and we're calling build, and we're passing in all of these command line variables. If you are using the quick starts or just doing a YouTube video and using the steps to compile, then you're not in control of your configuration, and it's going to be slow. It's just going to be slow. Okay. You want to do exactly what's needed, but not more. And so you need to control the command lines. And I've already worked out all the command lines. Please copy them, and please copy the project shell. You don't need to, if these command lines don't make sense, just copy these. I've already worked out how to optimize this. And for Azure pipelines, if you want to squeak out as much speed as possible, then take one VM and make a private build agent that is always around and always dedicated to your project. And that's gonna enable your build process to be as fast as possible. Migrating the database is just a command line to your database migration tool. Then unit tests and integration tests. We are specifying unit tests first, our unit test project, and then integration tests second. We also want to collect code coverage to have more information. More information is better than less information. And again, I've worked out all the command lines so that you don't have to. You literally can copy and paste this, and you're running the tests appropriately. And now, before I show you the script, we're going to come back to release candidate packaging. This is the structure that we're going for. We need a NuGet package for our web application, a NuGet package for our offline job, and a NuGet package for our SQL database, and a NuGet package for our acceptance tests. All right. We have a function called pack, which is short for package. And these are the command lines. Now, for for web applications and for test projects, we are going to need to call the publish command line for .NET.exe because there's logic that outputs the things that need to be deployed. We need to package up just the things that need to be deployed. So we use publish to publish it to a known location. Then we use an open source wrapper for NuGet.exe called Octopack. It's octo.exe. It's actually published by the company Octopus Deploy, which, by the way, also publishes DBUp, which is a really popular database migrations tool. And we're using it. This literally wraps NuGet.exe, but it simplifies the command line so much when creating archivable and deployable NuGet packages, okay? So what we're gonna do is we're gonna give it a name, we're gonna give it a version, and we're gonna point it to the directory path that we just published the deployable components to, right? Now, one difference is our database project. And if you look in there, the database project does not need to be published because it's not a native .NET Core project. It is a project container for all of our scripts. So we package up everything in there, not just a subset. But our offline job, we use .NET Publish, and our acceptance tests, we use .NET Publish before we package up the resulting. So that's, we get the same files. So you see UI project, database, job, acceptance tests, 4 NuGet packages, 4 release candidates. And now we've satisfied our transition from source code to a set of deployable release candidates that are all the same version number. Okay, so to review, I understand that is a lot of information, okay? 3 essentials, your CI build has to be complete, not just compiling. It has to be versioned. You want it to have a script that is stored with your application, and you use your build configuration to just wire it in, not to actually implement all of the logic. Because you saw every one of those command line switches. If every one of those command line switches was just in the build server only, well, then you couldn't even do things that required adjustments there, and you couldn't test them out on a branch because your build script logic was essentially global. Okay, so you want it to be local. You want it to be in version control. Therefore, everything in version control is branchable. Anything that's on your build server is not branchable. Okay, third essential is you want your team to rely upon it. It needs to be part of your team culture. And to review where we were in the code cycle, we were on our branch CI, which regardless if it's a feature branch or the master branch, you're always going to run continuous integration on a branch. And of course, to go to production, it needs to be off the master branch. Okay. And zooming back out to our Onion DevOps cycle model, we're seeing that the principles, again, the interior cycles must spin faster than the exterior cycles. And each layer defines done. So if you missed several weeks ago when we covered this we've been in code, but the team cycle, and we'll get to this next week, the team cycle is where you do pull requests and build off of master and decide, you know what, we have something that may be ready to actually be deployed to maybe product management's manual test environment, which is the product layer. And then the product management team, whoever that is, your product owner, says, you know what, I like this build. I think that we're ready to move this build out and deploy it for customers. And then the outer layer is where your customers actually use it. That's production. Okay. All right. So next week, we're going to be diving into full system testing. That means we're going to have to do our first deployment, and we're going to complete the things that are necessary for a pull request off of the branch and possibly into master. All right. So what's the next steps? Remember, send me an email so that I can send you a free copy of my book. And as you read the book, use the included Azure DevOps Services project template and literally get up and running within a day, really within a couple of hours. Also, be sure to subscribe to my podcast, the Azure DevOps Podcast. And next week, make sure to tune in as we dive into those full system testing and finishing out the pull request process. This is missing from so many teams, but it is a critical driver to enable you to move fast, build smart, and run with confidence. So I want to thank you. Thank you for your time, and make sure to share the recordings with your colleagues. And if I've mentioned something with past webinar recordings that you may have missed, then again, send me an email and I would be happy to hook you up. Don't tell anybody. I'd be happy to hook you up with recordings of the past episodes that really only webinar attendees receive. But if you reach out, I'm a nice guy. I'll get it for you. Okay. Because we don't just normally publish everything publicly. So thank you so much for your time. I know your time is valuable. And so dive into the book. I'm excited to get it in your hands and get the DevOps template, and send me an email if anything doesn't make sense. And I'd love to help you. Have a great day.